Good evening. I'm Michael McDonnell. I am the cybersecurity librarian. Thanks for joining me. So if you've seen these before, you know that every Tuesday I do a live stream about something technical. In the previous two live streams, sorry, some noise in my building caught me off guard for a second. People celebrating frontline workers with very loud horns. The previous two live streams, I covered some topics related to Docker and automating the installation of software in my desktop environment. This week, I want to cover something a little different, a little bit truer to my cybersecurity roots. Next week, on May 28th, we're supposed to receive the Windows 10 May 2020 update. It's got some cool new security features, including passwordless logon to Windows, which means you can use a PIN, not have a whole bunch of tokens related to passwords. I actually don't know much about that, but I want to talk about the secret password sniffer that's built into Windows 10. So in the October 2018 Windows update, they included a new utility called pktmon, pktmon. And it is a packet sniffer. So if you use Wireshark or TCP dump, it's kind of like that, but it has a few Windows-specific features. Having a packet sniffer built into Windows is not entirely new. For instance, prior to pktmon, you could type in netsh trace, and you could do a packet dump, and it would save it into a proprietary format called ETL. Pktmon also uses the ETL format. And if it weren't for the update that's coming out next week, I'd say, I don't care. I'm going to use Wireshark. And if I need to do a large packet dump without real-time visualization, I'm going to use the command line tools that come with Wireshark. So why do I all of a sudden say, oh, we should pay attention to pktmon? It's because next week, they're going to add a feature that allows you to convert the ETL format to pkmon format. That ability has existed for some time. In fact, let me throw a URL up on the screen. So if you go to this GitHub right here, there's a utility that Microsoft published a long time ago. I think it was third party, then they adopted it, something like that. And so in the past, you could either take netsh trace and generate your ETL file that contained your packet capture, or you could use pktmon to generate your ETL file with your packet capture. Then you could convert that ETL file into a PCAP, load it into Wireshark or TCP dump, or any of the many, many, many tools that support PCAP. So next week, we're not getting anything that we couldn't do today. What we are getting is that ability natively built into Windows 10, because you would have to go and install this and use it. And frankly, if I had to install something on a computer, I'm just going to install Wireshark. But the fact that we no longer have to have the extra step, it's not a big deal. It's not a game changer. But man, is it convenient. And then I thought, well, if that tool is going to be built into every Windows 10 system, it's probably time that we invested a little bit of effort in figuring out how this undocumented secret packet sniffer works. So I got this idea because the website Bleeping Computer, if you don't read it, you should. They have lots of great cybersecurity stories in there, not just technical stuff. So last week they wrote this story saying, or updated the story saying, hey, it's got a built-in sniffer. And then they, just like me, noted, hey, this thing isn't documented. We have to figure out how it works on our own. And I did the same thing they did, which is I sort of dove in and started typing in all the help commands until I figured out how it worked. And I thought, okay, you know what we need? We need a quick reference. Like, this is going to take an hour and we can have a quick reference. And so I have created a quick reference for this. And in my mind, it's kind of, well, I'm saying it's probably time that we learn the basics of this thing because it's going to be worth using in the future. It's going to be super helpful in troubleshooting problems where we can take a packet capture right with the same built-in tool, convert it to PCAP format, and then visualize it in Wireshark or what have you. Or I was thinking more like, oh, I could use WinRM, so Windows Remote Management, have a PowerShell that remotely starts a PCAP, grabs the data I need, and then moves it off to where I can, in a central place where I can collect it, and then I can analyze it and examine it and things like that. That would be a much, much better use case. Hey, Derek, thanks for the compliment, man. This is the second quick reference I've made in my life. The other one was when I was the SANS local mentor for the intrusion analysis class, and I made a quick reference for packet headers that actually aligned to the output that TCP dump has. I should publish that again. It used to be online for like 10 years. Fellow Albertan who was in my class, Derek Armstrong, many of you know Derek, he actually colorized my header thing. And then when I was producing this quick reference, I was reminded of Derek's innovation. Different Derek, not Derek Bodnerchuk, Derek Armstrong. And Derek colorized my first quick reference. And I thought, oh, okay, I'm going to colorize this one. And I don't think I'm not sure that this is the right colorization. So if you guys have got feedback, put it in chat or put it in comments or put it on my LinkedIn post. If you want to see the LinkedIn post where you can download this thing, I put the link for this quick reference down in the comments to this YouTube session. So it's not in the chat, it's in the comments, but it's also at this article, which you'll see right down there. Go to that bit.ly link. That is on LinkedIn, and you can get a copy there. I'm not sure what better way I have to publish it at the moment, since I haven't set up a website. Anyways, so I've created this. It does not have every single command, and in particular, I'll just mention now, it does not document the filter keyword. And when I dive in, I'm going to show you some examples of how this works. I'll explain why I didn't put the keyword thing in there, but it's actually really handy because these ETL files this generates don't just have packet captures, they have other Windows events. And I think that's why this is a super interesting tool, and it's why it doesn't natively save to pkapng, because it's saving more information from the TCP/IP stack or from the network drivers than simple packets. So if you're doing TCP dump, you're really just getting Ethernet and TCP/IP headers and things like that, the packet contents. in here, what we'll see in the example is actually logging a lot of what's going on internally. I'm assuming that's different network components from the network stack. I never even realized that with the previous net sh trace command, which I've used. And now I start thinking, how many times was I debugging some problem in Windows and didn't realize the ETL file probably contained some extra stuff other than packets that could have helped me. All right, so before I start in the demonstration, I want to show one extra thing. So when I started thinking about this new packet sniffer, I got really excited because I made an assumption. And Nathan, if you're in the audience watching, a little shout out to you. What I was thinking, I was like, oh my God, there's a new packet sniffer. It'll be PowerShell integrated. Oh my God, Nathan and I can do like a PowerShell workshop or something on how to do packet sniffing with PowerShell, and it'll be awesome. No, this tool does not have any PowerShell integrations. So then I was like, well, maybe I should just Google and see if someone's done it. And someone has. And I'm not going to say it's terrible. It's just, so what you see here on the screen, I'll make it a little tiny bit bigger. Okay. So this part's easy. You create a new network socket object, a raw socket. Okay, no problem. We'll read raw packets off an interface. Now we bind to that raw socket, and in this case, it's binding the loopback. But then, what we're going to want to do in a normal packet capture is filter. We're going to want to say only capture the packets between host A and B, or only on port 53, or only the SSH traffic, or whatever. And you can do that with this method. But if you're like me, you're more sysadmin than developer. It's been, the first 10 years of my career I was a developer, and I would have thought this is awesome. But as a sysadmin, I want one command line. I don't want to write a program. I don't want curly braces. I don't want parentheses. I don't want $signs. I want to get my packet capture. And so you can do it in PowerShell, but you got to memorize a lot more syntax. And this guy's saying, well, you can write a PowerShell commandlet and you can make this, a lot easier. And the great thing about the PowerShell thing is it will save natively in PCAP format. Okay. So if you're into that, Google for this article, packet capture on Windows without drivers. It'll tell you how to do it in PowerShell. The truth is we would use a tool like pktmon or netsh trace or Wireshark or TCP dump when we're troubleshooting. And I can see some of you in the chat. I've worked with you. Okay. Oh, panic. The system's down. Someone can't get online. Quick, I can write 10 lines of PowerShell. No, I can't. I will pull out the quick reference and I'll grab the packet capture. I'll get the data, then I'll start troubleshooting. I'm not going to remember how to be a developer. I could write some stuff in advance, but in the moment, during the crisis, we need simpler tools, direct commands that we work with all the time that we end up memorizing. And this ain't it. But pktmon is. So let's dive in. I am just going to share a PowerShell window. All right. So here we go. I haven't rehearsed any of this. That's why I love live streaming. If I were preparing this as like a pre-canned video, I'd like spend all Saturday and Sunday trying to make it perfect. It doesn't need to be perfect. I made the quick reference. That took an hour. That's all it took. It's just a Word file. By the way, if anyone would like to improve it, I've only shared the PDF, but I would be glad to give out the Word doc and have other people colorize it, like my friend Derek Armstrong did 15 years ago to my last quick reference. Let's dive in. So is this thing built in? Oh my God, it's been there since 2018 and I didn't even know. But there's no help. Go search TechNet. It's not even mentioned. You will find one page on TechNet that is a reference to the driver and how to disable the service or re-enable it if you've disabled it. However, there is built-in help into the command and it's quite useful. And if you want to explore, that's more than enough to get going. So for instance, we can say filter help, and then it gives us additional help and it says, the filter command is a bunch of subcommands. And we could say, okay, give me help on the list command. And it says, well, okay, it's going to display the active filters. How about the add command? Oh my God, there's a lot of options to the add command, which is why I made the quick reference. So let me explain the basics of how this works. If you're used to TCP dump, this is a bit different. So with TCP dump, you'd make one long command line and you'd say TCP dump -I, read from a particular interface, and then you'd maybe have some options. Then you'd have a bunch of filters in Berkeley packet format filter at the end. So for instance, you'd say port 53 and port 22, or you'd say from host and then an IP address. And you could build up all those filters together with ands and ors. And TCP dump has a really rich packet filtering language. If you were using Wireshark, you do that visually using their incredibly detailed set of filters and decoders. This tool's not as sophisticated as those, but it is good enough. The way it's going to work is the first thing you're going to want to do before you capture traffic is build your filters, and you add them one at a time. And I like that. Let me show you. So right now, we'll say pktmon filter list. There are no packet filters. Okay, let's add one. Now, as you can see in the scroll back here, there are a lot of options. And if you look at my quick reference, I focused on, let's make sure the quick reference covers the basic filters that you're going to use every day. Most of the time, I'm not going to filter by MAC address. I really like this idea of being able to filter on VLAN. I've used this in TCP dump saying, hey, just show me packets of a particular encoding type. And I'm telling you, if you're me, I've been living in IPv6 dual stack with IPv4 at home and at work for a year. And so filtering having both of these is good, but being able to filter them out is also good. And this has been my go-to for troubleshooting basic network problems forever. I've done this in TCP dump a million times where I'm just like, show me the ARPs. I just want to know if basic address resolution is taking place on my network. Is that my problem? No, it's not that basic. Let's crawl up the stack to the application. So this is all good, but let's face it, what we're really going to use is let's filter out the traffic between that includes a particular IP. Maybe it's the destination server I'm trying to connect to, or between two IP addresses, or more than likely, because this is going to run on an endpoint, we're probably going to see like a Windows host or server. We're going to say, oh, let me filter on the port. I should point out that it does let you do filtering by encapsulation, which is kind of neat. And the support is kind of okay. So you could say, you know, just show me my GRE tunnels. Have any of you ever seen a GRE tunnel on an endpoint? I haven't. I know it's possible, but I have no clue why these would be realistic cases. VXLAN, yeah, that could happen. IP and IP, yeah. I don't know exactly what I mean by IP and IP. If you guys know, tell me in the comments, educate me. Okay, so we're gonna add a filter, and let's just do a really, really simple one. Let's add port 22, SSH. Now, filter list. Okay. Right here, we are not yet capturing traffic. We are just building a filter set that we can apply later. For those of you guys out there, I know I'm looking at a bunch of you, you know Fortinet's platform. You and I have worked on Fortinet troubleshooting before. This is a lot like Fortinet's different debugging things, where you'll basically layer up some things and saying, well, I want these events and these events and these events, and now turn debugging on. And your screen begins to fill with stuff. And then you reset it and you change the filter and you say, no, 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 I didn't need all of those debugging messages. It's very much like that, but for packet filters. So let's add something else. Now let's say, let's add an IP address. Google's DNS. Oh, I got the syntax wrong. How did I get, oh, I forgot to type the subcommand add. Now it says filter added, pktmon filter list. All right. So now we have two filters. And here's the only really important lesson of the night. And I put this in big red letters in the filter syntax in the quick reference. Packets. What? Move, not more? Move, not more. I don't know what that means. Anyways, packets must match all conditions from at least one filter. So those two things are important. A filter can have more than one condition. So one of these lines here, like this, that could have two conditions. IP addresses are a great example. I can say packet font. So I've just added a filter that has two IP addresses. Now what that means is it's only going to capture packets that have both of these, so source and destination, and it doesn't matter which direction. But packets must match all conditions from at least one of the filter list. So if it's 22, or it's 8888, or it's 111 and 888, it will be logged. So within the filter, it is and combining all the filters is or, and that brings us to another feature. When you do add, look at this syntax. When I typed this, I did not include name. Name is optional. And you will notice in my filter list, it says the name is empty. Just one moment, I have to cough. All right. When you are building up your filter, you can give your filters a name. So we've added some filters already. pktmon filter list. Now let's do pktmon filter add, and then we're going to say SSH. Actually, let's do a different one. -P21. So traditional FTP stuff, data port, command port. Let's add another packet filter add, and we'll give this one a name. -P80. Now let's take a look at our filter list. It gives them names. From my experimentation, these names don't do anything. These filter names don't matter. It takes all of the filters and combines them regardless of name. But I just realized maybe that logic of packets must match all conditions from at least one filter, maybe it's going to combine this with an and then all of the named filters with an or. We should put that to the test because I did not test that when I was experimenting with this on the weekend. So let's just fire this up and see what it does. So to start filtering, you could just do this. And you'll notice it says active measurement started. And then we say stop. And because I've maximized the font, the formatting's all messed up, but it gives us a count of each network interface. So it was capturing every network interface all at once, which is, I think, a really interesting difference from TCP dump, because, you know, my normal way of using TCP dump is you pick one interface and you capture from one interface at a time. And then you get these statistics of, okay, out of everything we captured, what was the direction? How many packets did we see? Did we drop any? How many did we transmit? But the default output is in a file called pktmon.etl. No ETL file. That's really not nice. I really wanted my ETL file. Oh, well, that's because if I really want to capture it, I do have to tell it that I want to capture using this. I don't know what ETW stands for. Event tracking something. But it's not going to store the packets that it captures into a log unless you tell it this. And then by default, it will put it in a file called pktmon.etl. But you can specify any file name you want. And there are also a few really interesting options that you need to know about. So in TCP dump, if I wanted to listen to just one network interface, say my laptop's got Wi-Fi and it's got a VPN and it's got an Ethernet card, well, that's 3 interfaces, plus there's some built-in ones. I only want to listen on the Ethernet one, not the others. Well, with TCP dump, I'd say TCP dump-I, ETH0, ETH1, ENS 193, whatever. On here, you use this -C for component. And if we want a list of those, we use pktmon comp for components, and we say we want to list all the components, and then you will see that there is an ID number. So here's a virtual switch because my machine has Hyper-V. Another virtual switch. Let's find just the one we want. What? I think this is probably what we're looking for. Thank you, Nathan. ETW stands for Event Tracing for Windows. Oh God, I should, you know, this is like a reverse game show. I'm pop quizzing myself and you are all the judges. Now, if any of you can tell me why I can't find a simple Ethernet adapter in this thing, it's probably because of my use of Hyper-V and Docker for Windows. But I see this V-switch. I see this V-switch. And I'm assuming somehow my real Ethernet is consumed by that, and what I need to use is one of these IDs. But component IDs are how you restrict what you're going to listen to. So let's capture some data. And what I'm going to do is I'm going to go to ctemp, and already you can see I've done some packet captures already. Pktmon start etw -f test.etl. Now our output's a little different than the last time. Test.etl. Logging mode circular. Typical Windows logging fashion, and I quite like this feature as well. You can do this with TCP dump as well. Okay, so what happens when the maximum file size of your capture gets reached? Should you A, stop, B, create a new file and potentially fill the hard drive if you forget to stop it, or C, just rewrite the file. So keep capturing and start over, empty the file, and then fill it till it reaches the maximum size. And by default, it does circular, which means this file will grow to be 512 meg. Then it will go back to 0, and it will start filling it again over and over and over. You should pay attention to the default behavior, because if you're thinking that file is going to grow infinitely, it will not. However, you can use a command line option to specify the size and change this behavior so that it creates new files when it reaches maximum size. By default, it takes the file name you specified, just adds 1, 2, 3 as it creates new files. So that's pretty simple. Now let's say let's just check, and you'll see test.etl's there, but we don't have any traffic for it to capture. So in another window, I'm going to generate some HTTP traffic. So in theory, should capture that. Okay, so we got some packets. Still 0. Now let's stop it. Might not be flushing it. A lot of tools that I've worked with in the past do not flush their output unless they have to. So your file will always be 0 bytes until you stop it or find some way to flush it. So pktmon stop. Now it's stopped. And it says, okay, here are all our statistics. Let's take a look at that file, and look, now it's flushed all that data, and we have a lot of files left. Now, this file is in a custom format. It's a binary format. And until next week, if you want to use the output, you have to convert it. And to do that, you use the format command. The format command lets you specify an ETL file as input, and then a text file as output. Oh, I meant to show you the text file, not the ETL file. So here is our output from our file. You could parse this with a regular expression. It's CSV, so you could load it into a spreadsheet. The ETL file is readable with a discontinued Windows tool called Windows Network Monitor. I've only had to use that once, and it was because I didn't know that ETL to PCAP existed as a program. You will notice, though, there are things in here that are not packets. These are not just packet dumps. So look up here. Here's an entry. Destination IP, source IP, protocol, destination port, source port. Hey, that's packet capture. What the heck is this? Like, this is, I think, useful and interesting. This is some other information coming out of the network stack. That could be useful if I understood what it meant. I'm sure I can Google that stuff, figure it out. But it's that's where this other command comes in. So when we were doing filters, oh, it's not actually a filter. It's pktmon start help. When we start pktmon, we can say, you know what, I only want you to capture certain things. For instance, we could say, only show me dropped packets. You're troubleshooting a performance problem. That might be useful. Just show me what is not making it through. You know what? By default, it's only going to capture 128 bytes. So I can say, well, when you start this capture session, capture the whole packet. But then there's this cryptic little guy, keywords. And it's in the format of a hexadecimal bit mask. And the examples sort of tell you what's going on. It's logging more than just packet data. If you just want the packet data, 0x010. But it's also capturing network configuration events, component-related information, including counters. Okay, counters are nice. If I were troubleshooting on a firewall, that's one of my go-to strategies. Pre-parsed packets. And I'm really wondering what that means. If you guys have an idea, let me know, because I'm drawing a blank at the moment. On the other hand, prior to this, I hadn't looked at a packet in 6 months. So, and then out-of-band packet data. So all those other entries were this non-raw packet information. And I think if you were troubleshooting something that turned out to be Windows related, like a driver issue or an application issue or a bug, that information is going to be more useful than the packet data. But if you're troubleshooting a network problem, which is what I would be doing with this, I might put that keyword when I do pktmon start. Now, what doesn't work today and will work next week is and this data, I got this out of the Bleeping Computer article, and I confirmed it with a couple other sources, and the way they determined, so right now if you use the format command, it'll take an ETL file and let you put a text file out. Starting next week, and this was confirmed by people downloading the preview version of the update, there will be a syntax that says pktmon pkapng, then you put in your ETL file, and then you can output a pkap. There are actually options to this as well. And if I type help, it won't work because I'm not running the preview version. I don't have this functionality yet, but there will be an option to only include drop packets, or to only include packets from a particular interface. So you could capture all of the packets, but then when you produce the pkap, you could include just those from a particular interface. Quite useful. All right. There's one last thing I want to do, which is I want to go back and clear my filters, and I want to do a filter example by those names and see what the logic is. But before I do, I'm going to give you guys an opportunity to type any questions into the chat area based on what you've seen. And then I'll move on afterwards to test this logic out that I hadn't experimented with before. So one of my questions that I generally have for everybody is, are you going to use this, or are you just going to install Wireshark? And then my second question is, for those of you who've used Wireshark to perform packet captures, do you do it with the GUI tool, or do you do it with the CLI tool? Has anyone actually used the CLI tool that comes with Wireshark? It's weird for me because there's a lag from the time you see me asking the question to the time that you might type a response. There's a lag. I'm going to continue, and if I see a chat message pop up, I'm going to like, all right, I'll answer that. In the meantime, let me go filter, remove. Okay, so first let me list the filters. Here's all those filters we added. I want to remove those. Really important part about this remove command. Oh, okay. Yeah, Nathan. Yeah, mostly I would just load pcaps I got from TCP dump somewhere else. And Ryan says he uses the GUI as well. And Derek, I assume that what you've done is probably use that captures stuff in FortiOS and then convert it using that weird converter, because theirs isn't in pcap format either. Though I think they were adding that about the time I stopped last year working with that stuff. So Ryan says that with pktmon, be interested in the results he gets with it. Yeah. This was kind of interesting to me too, Ryan, was the reason why I originally thought, oh my God, PowerShell integration. What I'd really like to see is a pktmon command that is a PowerShell commandlet, where that I can then make the filters on a single command line like I would with TCP dump. But why would that be good in PowerShell? Well, because PowerShell deals with objects, I could build up those filters programmatically. I could get the IP address by pulling an Active Directory object or a DNS object or something and make a list, and then have a single command line saying, start capturing, here's my filter. I'm not even sure I'd use it if I had that ability. But I kind of feel like that's the PowerShell way, to use the object-oriented nature to build up lists dynamically in the command line. It's what Nathan and I have been doing with threat hunting in the past, is if you want to use WinRM, you don't tell the other end to execute a command. You literally pass in a bunch of arguments and it goes and fetches the data and brings it back. You can combine a lot of data from multiple sources. And I kind of thought, oh, well, this is new and interesting information. What if with a single WinRM command in PowerShell, I could grab packet captures from multiple places, and then ultimately, what if the output came back in a way that I could parse that and then pipe it into more PowerShell? I mean, yes, I could write a PowerShell command that does that, but I'm not. I want it to exist. I'm a sysadmin, not a developer. So anyways, I'm going to get, okay, let me go back to what I was showing you before here. pktmon filter remove. It does not work the way I thought it did. My intuition was, oh, I will simply say remove this, and it would just take care, get rid of those and leave those. Doesn't do that. The syntax is remove all, no matter what. So you can add filters one by one, but you cannot remove them one by one. And if you had built up a complex set of filters, heartbreaking if you had to remove them all at once. So again, I'd like to build them up programmatically. And Barry says he was hoping to use for remote troubleshooting, but the end users don't have admin access to run this on their machine. And this is why I would want to use WinRM. And you could still, you can invoke a remote command, a DOS command this way as an administrator, but you have to have WinRM set up, which isn't hard, but it does have to be set up in advance. And you are correct. This, you'll notice in the top part of my window, let me make this big. Sorry, guys. I got distracted and didn't make it big. This says administrator. You must run this command as administrator. Nathan says, hey, what about remove ID? It doesn't work. Say I go number 7. I just want to remove 7. Removed all filters. It ignores everything you put after remove. So I could say, it removed all filters. Yeah. Yeah, this is one way to do it, Ryan, for sure. For sure. Okay, let's do this experiment. So we are going to add named filters, and the purpose is to see if the Boolean logic, again, that logic for filters being, in order for the packets to capture, they must match all conditions from at least one filter. So if a filter has multiple conditions, it must match all of them, but it only has to match one of the numbered filters. And I'm thinking, if I give the filters a name, maybe what it's going to say is, well, I want it to match all the conditions under that name. Be totally cool. Yeah, Barry, you know why the reason why some of us here are really excited about PowerShell is because we're totally new to it as well. So Nathan and I taught a threat hunting class last November. And this was really, even though I had done some PowerShell training, like it was my first exposure where I thought, oh my God, I'm on board. Up until then, I mean, despite having security training in Windows that's quite deep, I've always been a Unix guy. I started my career as a web developer. I was a Unix sysadmin forever. And I was like, PowerShell, that'll never be as good as the command line. And then all of a sudden, when Nathan started teaching me a few tricks in PowerShell, it was like, oh my God, it's the Unix pipeline, but this object-oriented thing and the new WinRM is amazing. And then I had a client at, well, I won't name them, but they might be in the audience. You guys know I love you. They are excellent with PowerShell, and they showed me PowerShell Core on Linux. So you can have PowerShell on Linux, PowerShell on Windows, and then use WinRM using the SSH mechanism and start sending commands from Windows to Linux, from Linux to Windows. It's freaking amazing. I'm never going to fully go away from my Unix roots, but I am totally on board with PowerShell. And then Kali Linux, the pen testing Linux, just released a new edition, the 2020.2 release, and PowerShell on by default. And I'm telling you, when I saw that, I'm like, of course PowerShell's on default in Linux. Of course it is. Most of my use cases these days involve interaction between Linux cloud services or Linux auditing workstations or whatever against Windows infrastructure. Like if you're interacting with Azure, moment to moment, you might be doing something with a bash script and then a PowerShell script and whatever. Guys, trust me, get on the PowerShell bandwagon, even if you're in Unix, because it's like having your cake and having a cherry on top. It's nice. Okay. Yeah, Nathan, I would expect this to throw an error as well when I remove stuff, but this may be why it was secretly added with no announcement, no documentation. Like they put it in there. Here, ask yourself this question. Why does pktmon exist at all when its output is ETL files, and historically in DOS or historically in cmd.exe, we had netsh space trace. If you never used it, that's the way you used to get a packet shell or a packet capture natively in Windows. And so when pktmon was introduced in 2018, it was kind of like, does it do anything different? And I think it actually does do a few things different, but like honestly, this isn't like a really huge deal. And I don't think they put a whole lot of coding time into it. And obviously they don't want to support it or they'd have official docs for it. I think the only reason why we're getting pkapng support in it is because they'd already written that, had it on GitHub, and they said, you know what? I mean, the sysadmins there, Microsoft probably wanted it built in too. The MVPs probably wanted it built in, and they said, we've got the code added. Okay, where was I? Okay, let's test this logic. Pktmon filter list, I've got nothing. So let's create a couple named filters. Let's create one for FTP, and then let's create one for, can we do ping? How do we do ping? That's a good question. Oh yeah, yeah, okay. So it's in my quick reference card. So it would be the -T flag, and instead of saying TCP, we'd say ICMP. So let's do a couple filters, and then let's try to generate something that it would or wouldn't capture logically. And this is where you get to watch me embarrass myself, which I said in the description of the live stream. Making this up as I go along. It's pktmon filter add. And we're going to name this one FTP, and it's going to be TCP port, and we'll just put 21 in there, port 21. And then let's do pktmon filter add ICMP. Let's just call it ping. Type ICMP, and you know what? We're going to cheat. In theory, what we'd have to do is use one of the other flags and I see no example, so we'd have to experiment. So ping is ICMP type 8 with two subtypes, ping and pong, the request and the response. Common mistake I've seen on some of the firewalls, the people watching, is that you put in a firewall rule and you mean to allow ping, but you allow all ICMP. Or you put a firewall rule in and says, only allow ping, but you forget that certain failure conditions have to allow an ICMP response packet declaring the failure condition. ICMP is often confused with ping. They're not the same. I'm going to cheat and just say ping equals ICMP. Now let's do another more complex one. Let's call it web. And we're going to say TCP port 80. And we're going to call it TCP port 443. Now let's list our filter. Now, the logic again is packets must match all conditions from at least one filter to be logged. And the question is this a filter because they share the same name, or are these separate filters because they have different ID numbers? I don't know. It's not documented. Let's figure it out. So pktmon start ETW. Also notice with ETW, it's one of the few commands that is double dashed. So they're following general Linux conventions or GNU conventions where it's, if you've got a long name and a short name for the same command, like port is -p, then --port is the long version. But I don't think there's a short version of this in any case. And let's do filter test.etl. Now, to test this, I'm going to generate some port 80 traffic. So off screen, you don't see it, but I'm loading a regular port 80 page. Now let's stop this. Let's have a look at the filter test. Now let's output this into text, because I don't have the GUI utility, which I believe is called Microsoft Network Monitor, which can natively parse these. It ain't no Wireshark, but it's actually okay. Like it does have some packet decoding capability. I've used it in the past, but I mean, Wireshark is king for a reason. Pktmon format filter test -o filter test.txt. Now, let me load this up in a text editor and share that window with you. Give me one moment. Yes, text. And share a new window. Okay. And let me reduce the zoom on this a little bit. I want to make it readable to you, but also see what we've got in here. So we've got a lot of these checksum files. We got some drop packets. Let's see if we've got anything with the destination IP in it. There we go. Now, what do we got here? Okay. So my test traffic was port 80, but this was capturing port 443 traffic as well. Let's have a look at all the ports. Do we have port 80? Original size. Port dest 80. Oh yeah. Do we have any ICMP? Oh, look at that. So as soon as it ends, you know, it dumped the statistics, but it also dumped what filter were in place. And that answers my question. So just because this is named web and this is named web, it doesn't treat them as one filter. It treats them as separate filters, which means that all packets must match all conditions from at least one filter. So can we, let me go back and share this window again. Can we specify more than one thing in a filter? Ah, we can. So we could do this. Just port 22. No, let's do this. Just ICMP, and we better remove all the other filters first. Just type ICMP and just between, and just going to port 888. And let's go a step further. Where's my quick reference? Let's do just IPv4, which I mean is overkill because this address is an IP4 address, but just to show this. Now let's look at our pktmon filter list. Aha. So now we have more columns. So the packet would have to meet all of the conditions in this filter. But if I were to add a second one, that's just this. Now think about it for a second. Must match all conditions of at least one filter. This one's really broad, so it's always going to match. And if I'm thinking I'm only going to get ICMP packets to 888, well, I'm sad to say that it's going to get all my ping packets because it's going to match this one. So Nathan says, does it have a field to show which filter matched by a packet in the capture? Oh, this is why you are king of the questions, my friend. Okay, let me switch screens back to the data capture because I think it might be included in that output. Where is that window gone? There we go. So let's scroll up and search for port dest 80. Now, is there anything in this line that indicates which... Oh, Nathan. Oh, man, I miss working with you, bud. You were so smart. It does say which filter caused that packet to be captured. It also says which component, which corresponds to the interface. So you'd have to look those up. I don't know what this means. But if we scroll all the way to the end, packet number 3 is this one, and that's why it got captured. So if you did have to have a few filters and they were complex, you could troubleshoot this. That is super smart. Super, super smart. It also does list the component IDs that were included. So if you needed to know which interface it was, you could go to the end of this file. Now, I think one of the things we'll have to be interested in next week when the updated tools introduced is, okay, in the PCAP version, what name do they put in for the interface? Because, you know, when you have a PCAP and you dump that, it'll tell you that it was called ENS 192 or ETH1 or WLAN 0 or whatever it is, you know, in the Unix world. And so what's it going to put in the PCAP? Is it going to put in ID2? Because that's not going to help me if I centrally store these for analysis later, or if I have to share them. Or is it going to put in this? I would accept that, I guess. This could be useful as well, though for me, a little bit more cryptic. Like, I don't know if you can see what I'm highlighting. Let me zoom in a little bit. So here's component ID 2, and it's saying that's Hyper-V virtual Ethernet interface number 2. Now, if that was in the PCAP, even though it's longer than what I expect in Unix, I'm totally cool with that. Because 6 months later, if I'm using that packet capture, I understand what that interface was. This, which is the component name from the driver, that helps me. I can look that up. This is too generic. Maybe these two together. But this, I hope this is not what they're going to put in the converter. I suppose we could check now. We could go and get the existing tool off GitHub, the ETL to PCAP-NG tool, and see what it does. I'm sure that next week, that's all it's going to be is the same code. So, yeah. I don't know. I think, yeah, this is going to be useful. And I'm wondering, do I need a page 2 of the quick reference with some more realistic examples? And that's a question I'm legitimately asking you guys now. Is you've seen the quick reference. You've seen me embarrass myself struggling with fiddling around with this in real time in front of you. What do I need to put into this quick reference to actually make it real? So, you know, like 4 months from now, a year from now, I'm going to need to use this and I'm going to remember it. I'm going to say, hey, I wrote a quick reference. Let's pull that out. Is that quick reference going to be enough for me 6 months from now to go, aha, I can remember the lessons I just learned? Yeah. I don't know. I think there's going to have to be an update to this quick reference with maybe what it needs is just sort of one complex example to call out in this thing. Let me just share this window. Oh, shared the whole screen by accident. Okay, there we go. Maybe what I need is an orange box. You know, it's about the size of this one, that just has a multi-line example, you know, from start to finish, showing a reasonable example with some output. I think that's what I would want. If you're using it 6 months from now, things may have changed. You'll end up having hit the help anyways. I disagree. This tool was silently and secretly inserted in 2018, and it hasn't been updated since 2018 and not documented. I think in 6 months, this tool is still going to be there unchanged, and I don't think it's going to change again until, you know, the 2022 update to Windows 10, at which point they will have dropped the 10 off of it, called it Windows X, and it'll be a rolling update, like all the other OSs in the world. Sorry, just getting on my soapbox there for a second. No, I think this tool is going to be super useful, but it isn't going to change much. And I'm not going to use it that often. I'm still going to use Wireshark, but I'm going to tell you, if I'm doing an incident response scenario or helping someone or doing a threat hunt, I think I would love to use the native tool. And in particular, what I'm really interested in is being able to use this and fire off a remote command through Windows RM, through invoke PS session, whatever, through the new SSH support in Windows 10. I want to do that remotely from a trusted administrator workstation. I want to fire off a little thing that grabs my data and then moves the ETL file or the exported PCAP into a central place for me to analyze. And I can see a few threat hunting scenarios where I might take samples of traffic and then centralize the PCAP NG ingestion and literally automate the ingestion into a system that does some analysis. Think like the kind of thing we do with Zeek today at the network level, but let's capture from the endpoint just to try to get some of the same data and try to get it ingested. I think I would use this just because it's built in and just because it can now do PCAP export. I could do it without it, but it's built in. I'd probably use it. Okay. I'd love your more questions or feedback. I think I don't have anything left to demonstrate unless somebody's got an idea. Totally looking forward to any feedback you've got. You can, whether if you're watching this later when it's recorded, you can put those down in the comments for this, or you can go over to the LinkedIn post. LinkedIn's not great for long-term discussion. Oh yeah, we have a Discord now. We have a Discord for these live streams that I do. Where is that Discord URL? Give me one sec. Okay. There. That is the Cybersecurity Librarian Discord, which is a little experiment we're doing. For those of you who are watching my live streams for the first time, my friends and I, we do some other live streams. If you go to my YouTube channel, you'll see those. So my friend Moro and I, every Friday, we do one, and it's not technical. It's more like being in IT and cybersecurity. What's the profession like? What are the professional issues? All of that sort of stuff. Oh, we have a good question. Okay. Can it act in promiscuous mode and sniff the whole network? Okay, we can test that. That is a great question. Okay, let me... Oh, I did it again. I am not king of the live streamers. I have technical difficulties. You should have seen last Tuesday, the first 5 minutes, I didn't have my mic on. Fortunately, it was just Moro watching, and he was very forgiving. And then I restarted after 10 minutes. It was left in the recording. Total blooper reel moment. Okay, that's on it. There we go. There we go. Promiscuous mode. Well, first, let's see if it's referenced anywhere, and if it wouldn't be a filter, that would be a start time option. I believe it probably does this by default, that it probably goes into promiscuous mode because it, like, TCP dump has to. But would that help you at all in a switched network? In a VLAN-based network, you might see some traffic that isn't your own. In a hub-based network, you would totally see all the traffic on the network in promiscuous mode. But think about today. Like, let's forget pktmon for a second. TCP dump on a Linux machine. By default, it's going to put an Ethernet interface into promiscuous mode, and you're going to see any packets that are received on the Ethernet interface, whether they are intended for your host or not. In a switched network environment, you would expect to see very, very few packets that were not intended for your host. Which ones would you expect to see? Broadcast messages at the Ethernet level. So some DHCP traffic and some ARP traffic. I am certain that pktmon must put the interface into promiscuous mode. There's really no way around it. But the question is, what are we going to see? So let's just have a little look here and get rid of that banner. So you'll notice there's no mention of promiscuous mode here. It's going to just have to do that no matter what. That's probably why it has to be run as an administrator, because only an administrator can put an interface in promiscuous mode. For those of you who may not have had to do this kind of troubleshooting in a virtualized environment, when you go, you'll find that, say, in VMware at ESXi, you'll try to put a VM's Ethernet interface in promiscuous mode, and it won't work. And it's because the virtual switch or the virtual NIC has that permission disabled by default. And that's because in a certain types of virtual networks, if you put one interface in promiscuous mode, you get to see the traffic from everyone on that virtual host, which is not the way it works on a physical switch. So you have to really do that with some caution, especially in a multi-tenant environment. I think if we go back, we might see some ARP traffic that was already captured. That's what you would normally see. Oh, but that was not in our filter. Okay. I'm going to leave this one as an exercise to the reader rather than playing around with it. But yeah, I think you're right, Ryan. Promiscuous mode is there, and you will not sniff the whole network unless you're on a VM or unless you're plugged into a hub, or if you're a old school network hacker, you know that if you flood a switch with too much traffic, many switches will start to behave as if they are hubs. That is, packets that are meant to go switch port to switch port will now be broadcast to all switch ports. It's an old trick that if you need to sniff traffic and you have promiscuous or administrator access to a single host, overload the switch, not for the purpose of taking it down, to make it overload and then sniff all the traffic. I once worked at a large regulated industry 20 years ago now, and it was all of our switches in the entire organization across the province were severely overloaded all the time. I believed that they had hubs till I talked to the network guy, and he's like, no, our switches are just overloaded. And I was able to sniff traffic constantly, which made the security assessment I did for that institution really, really interesting. Any other questions or feedback? I totally went 20 minutes over what I thought it was going to go. All right. I'm going to wrap it up. Thank you so much for watching. I hope you found this useful. For those who haven't joined me before, why do I do this? Because I love learning, and I've always found I learn best by showing other people what I've learned. I really haven't mastered it until I can explain it. And so for the last 16 years, I've been sharing what I learned at every opportunity. And Moro got me addicted to live streaming, and I'm just not going to stop. So every Tuesday, or when I'm lazy, every other Tuesday, I'm going to share with you on Tuesday nights the little things I've learned and played around with. Right now, mostly that's Docker, but it could be things like this. On Friday nights, 7 o'clock, join Moro, myself, and all of our friends as we discuss issues related to cybersecurity. This week, a very fun topic. We're going to be discussing cybersecurity and hackers in public media. We're going to watch clips from a YouTube playlist and just critique and comment and discuss it. It's going to be super interesting. All right. Thank you very much, guys. And I hope you'll drop by next week.